Okay, so this problem you sent me is a tricky one, and I would suggest reviewing a few things first before we go on to the answer, to the solution. First of all, if you go back to section 3.6, formula 4, you will see that, interestingly, the derivative of inverse tangent of x equals 1 over the quantity 1 plus x squared. And obviously that's not intuitive, but if you're curious, you can go back and see how they derived formula 4. They go through the derivation. It's not too complicated. But anyway, this becomes an important formula to remember for this problem we have. Secondly, you might want to take a look at example 5 in this section on integration of parts, section 5.6, example 5. That's a good way to kind of warm up for the problem at hand. And then secondly, or thirdly, we're going to be asked to evaluate the tangent, inverse tangent of 1. And again, when I look at this, it just doesn't click, and I have to think, oh, okay, well, let's say z is equal to the inverse tangent of 1, then that means the tangent of z must be 1. When is that the case? Well, okay, for the range that we're looking at, and again, they talk about limiting the range, I think somewhere back in the section 5.6. But the range that we want to consider is, I think, negative pi over 2 to pi over 2. In any case, the right answer for this, what tangent of what angle equals 1? It's pi over 4. Or I should say pi over 4. Yeah, pi over 4 equals z here. Using similar approach, you can say, if you're evaluating the inverse tangent of 0, you think, oh, what tangent of what angle equals 0? Well, that's when the angle equals 0. So keep all that in mind, and we'll just go ahead and work on this problem. So here it is, and we want to use this notation for solving it, which means we have to actually work with this quantity, and so we need to define u and v and du and dv. So let's do that. I've done that here. We're going to let u equal the tangent, inverse tangent of x, and we're going to let dv equal x dx. And then we can say, taking the derivative of u, well, that's going to be 1 over the quantity 1 plus x squared times dx. And then v is just going to be the antiderivative of this, which is x squared over 2. Okay, so let's go ahead and make those substitutions. Here we are. We made the substitutions. You can stop the video and go through just to convince yourself that we've done this right, or that I've done this right. But those are the substitutions. Yeah, so let's go on to the next step. Oh, so here's the thing. This quantity could be a little bit tricky. And there's a clever solution to this, and I didn't see it right away. I had to get some help online. But it turns out if you add 1 and then subtract 1, that's equivalent. And that allows you to use this substitution. This is just basic fractions, but we can use this substitution for this quantity, and you'll see how it makes it easier. So here we go. From now on, or for the next several steps, I'm just going to put ditto marks for this first quantity, because that's not going to change. We have to work on the second part. So what I've done here is simply take this equation and plug it in for this. And you can stop the video if you want and convince yourself that you wind up with this quantity. Okay. And now, next step, Again, ditto marks here. This, of course, is just 1. And so that's simple. And this, we get to use that identity. And when we integrate here, we get inverse tangent of x. So now things are looking a little bit better. Let's go ahead and go to the next step. Again, ditto marks here. Now we go ahead and integrate this. It's just, we wind up with just x minus inverse tangent of x, all times 1/2. And now I'm remove the ditto marks, and I've brought this down here. And I've factored through by 1/2. So it's minus 1/2 x, and then this minus and this minus combine to give us a plus sign, so it's plus 1/2 inverse tangent of x. And now we can factor out 1/2, and then for this term and this term, we can also factor out inverse tangent of x, and then it becomes x squared plus 1, because we've already factored out that 1/2, and then all minus x. And again, you can work through that if you're not convinced. I think you'll find that that is correct. And so I've just written that in here. And now what we do, now that we've got this in a position where we can work with it and just do some calculations. But let's go back and see what we've done. We've gone from here to here, and we've just been focusing on indefinite integrals just to keep things simple. But let's go ahead and make this the definite integral that we really want. There it is. So it's from 0 to, we're evaluating this integral from 0 to 1, which means we want to perform this calculation here. And you can do that on your own if you want, but if you want to see it worked out, you plug in 1 first, and inverse tangent of 1 is pi over 4, like we talked about. This quantity simply becomes a 2, and then this, of course, is the 1. And then over here, when we plug in 0, we get 0, 0 times 1 minus 0. Anyway, this becomes a 0. Okay, so we're left with, you could write it 1/2 of pi let's see, I got a little lost there, but you wind up with pi minus 2 over 4. I think that's clear. Oh yeah, so it would be 1/2 times, this would be pi over 2. That becomes pi over 2 minus 1, and that becomes 1/2 times pi minus 2 over 2 equals pi minus 2 over 4. There you go.